is the transition of gas to liquid when it loses heat. A condenser serves to turn refrigerant in hot gas state into liquid form by taking away its heat. The refrigerant passed through a condenser becomes liquid and flows into expansion valve. There is a section in the expansion valve where the piping gets narrow, and as the refrigerant passes here, it splits up into many pieces. What we see here is similar to the principle behind water being spread from spray. As the pressure on the refrigerant drops, its temperature drops dramatically as well. The refrigerant with lowered temperature then goes into an evaporator to steal away heat. An evaporator is literally a device that evaporates liquid into gas. Cooled refrigerant steals away the heat in the room and evaporates. The compressor and condenser are built inside the outdoor unit of an air conditioner. The evaporator and expansion valve are built within the indoor unit of an air conditioner, which is what we normally refer to when we talk about air conditioner. Now, let's dive deeper into the functions of each mechanical components of an air conditioner. In the evaporator, refrigerant loses heat and is evaporated as gas into the compressor. When a piston compresses the gas refrigerant, its pressure rises, and so does its temperature.
So laging tandaan po ha, high pressure, high temperature, low pressure, low temperature. So laging magkasama.
We use products of spray type sometimes. You might have come across insect repellent spray or butane fuel canister whose surface of the can gets cooler after use. This is because the pressure inside the product has become lower. If pressure is lowered, temperature is lowered, and if pressure goes up, temperature also rises. Now, coming back to the case of an air conditioner. When gas with low pressure and temperature is pressed by piston, its pressure rises, and so does its temperature. However, more air conditioners nowadays use scroll type of compressor rather than piston type. In a scroll compressor, there are two scrolls of which one is fixed and the other rolls constantly. As more air coming through the entrance gets inside the scroll.
Okay, so yung kanina, is a different type of compressor. So ito, iba naman na design. But the function is just the same to compress refrigerant. Okay?
Space becomes crowded. As there is less space now, gas becomes more compressed and is discharged from the middle of the scroll in a compressed state. The reason for using such type of a compressor is the efficiency of space utilization. This type of a compressor allows the machinery to become smaller in size and reduces noise as well as vibration. Compressed air is then sent to a condenser to be pressed into liquid. The temperature of refrigerant passed through the compressor is above 80 Celsius, which is in a hot gas state. This refrigerant passes through
So there's just a small amount of drop in temperature, okay? But it is still in high temperature. So the gas turns to liquid in the condenser or in the high side. From gas to liquid, sa evaporator naman, from liquid to gas. So, ganun po yung setup nila.
Condenser and is cooled down slowly with chilled air from fans. When liquid evaporates, it absorbs heat and becomes gas. As it transforms into gas, its kinetic energy becomes stronger. When the gas loses heat, its kinetic energy becomes weaker and it becomes liquid. In other words, chilled gas becomes liquid. A refrigerant in gas state of high temperature loses heat as it passes through a condenser. As such, it becomes condensed and at the exit, it turns into liquid almost. Although the refrigerant has thrown off some of the heat as it passes through a condenser, it is still hot, with temperature at about 50 Celsius. The refrigerant in high temperature and high pressure liquid flows into expansion valve. The refrigerant which used to flow in large space now passes through narrow area, and its pressure drops as it goes. When the pressure drops, temperature drops dramatically as well. The cool refrigerant is now sent to an evaporator. Expansion valve are connected to sensible heat storage that detects heat.
Okay, so this is your expansion valve. So nakikita nyo dito, ayan, ito yung sensing valve. So meron din po siyang refrigerant sa loob. So pinupush niya, pag sobrang init, nag-evaporate po siya, pinupush niya yung diaphragm nitong expansion valve. Then tinutulak ni diaphragm itong needle. So once na tinutulak niya yan, nag-open yung expansion valve. So allowing the refrigerant to pass or enter the evaporator. Pero kung hindi ganun kainit, so hindi niya mape-pressure down yung diaphragm. So limited lang din yung papasok na refrigerant. So ganun lang yung principle ng expansion valve.
Sensible heat storage is installed on the exit of an evaporator and detects temperature. Inside the storage is fluid sensitive to temperature changes, and as the temperature at the exit of an evaporator rises, the gas pressure rises, which in turn presses on a spring to send more refrigerant to evaporator. When the amount of refrigerant going into evaporator surges, cooling emission surges too. When the temperature at the exit of an evaporator drops, gas pressure drops and the amount of refrigerant going into evaporator in turn drops too. Applying the above principle, an air conditioner.
Ayan. So umaangat siya pagka hindi ganun kainit yung evaporator outlet. So hihinto yung supply ng refrigerant. Until such time na uminit ulit, then mag-open ulit yung thermostatic expansion valve.
Conditioner controls the amount of refrigerant injected into an evaporator to prevent overcooling. A refrigerant passes through the pipes of an evaporator and takes away heat in this process. As the pan underneath.
Okay. So to prevent cooling or pagyeyelo, pagka nagyeyelo ang evaporator nyo, papatayin nyo lang, ilalagay nyo lang siya sa fan. Okay? Fan. Huwag nyo papaandar, huwag nyo ilalagay sa low cool or high cool or medium cool. Kasi pagka nandun sa setting na yon, umaandar ang compressor, yung refrigerant continuous na iikot sa system. So pagka naka-fan lang, yung blower lang ang aandar, so unti-unti niyang mas mabilis niyong mapapatunaw yung yellow kung sakali man nag-form sa evaporator. So mas mabilis po siyang matutunaw gamit yung blower lang. Okay? So ilalagay niyo lang sa fan setting.
Starts to operate, warm air in the room is sent to an evaporator and cooled air is emitted. Fans used in the indoor unit of an air conditioner is shaped as cylinder rather than the more familiar version of propeller. Such type of a fan is called impeller. As wall-mounted air conditioners cannot take up large space, impeller type of fan is used instead of propeller type. When you leave a cold glass in the air, its surfaces is covered with water. This is because gas has lost heat to be condensed. Pipes flowing with cold refrigerant are also covered with water drops on the surface. The water here is stored in drain pan, and when there is certain amount stored, the water is discharged through the pipe and out to the world.
So sa window type, so kaya natin ini-incline yung ating window type aircon kasi nga sa evaporator malamig, either pwedeng tumutulo yung tubig, yung malamig na hangin nagiging water droplet, so possible na mag-build up ng water doon sa ating evaporator. So kaya tinitilt natin siya ng konti, allowing the gravity to pull the water out the unit. Okay? So any question dito sa refrigeration cycle? Kasi ang alam ko hindi po lahat nakapag-recite. May tanong po ba? May concern about refrigeration cycle? Class, naririnig ba ako?
Yes, sir.
May
Yes,
tanong
yes,
po
sir.
ba? Malinaw naman?
Yes,
Sir,
Yes
may
po,
tanong
sir.
po ako, sir.
Yes, go ahead, please.
So, normal lang yung nagtutubig yun, sir? Normal lang po yun.
Normal lang naman. Huwag lang yung sobrang bumabaha na yung diyan sa kwarto mo. Normal yan kasi may malamig yung area. So syempre may mga konting water droplets pero hindi naman na sobrang at in talo na yung gripo na nagtutubig. Okay? So konti lang, ay droplets lang, unti-unti siya nagko-form. Normal lang naman 'yun. Basta naka-tilt lang ang yung unit para gravity will work on your unit, yung water. So mawawala din 'yan. Any more question? May tanong po?
Wala naman na, sir.
Wala naman. So in some cases, kaya nag-yellow rin ang inyong evaporator, either madumi. So marami na siyang dust particle na nakabara doon sa evaporator coil. So kailangan nyo lang i-check every now and then. So yan naman ay nililinis every 6 months. Pero kung napansin nyo na madumi na, linisan nyo na. Especially yung filter, lagi nakakabit kasi mas madali linisin kung yung filter lang ang madumi. Kung yung coils na ang madumi, kailangan mo na gumamit ng water pressure or pump to clean the coils. So medyo hassle na yon. Kaya as much as possible, nakakabit lagi yung filter para yun lang ang lilinisin nyo lagi. So mas madali pa yung linisin at kayang-kaya yun na linisin ng kahit sino. So walang bayad kang gagawin kasi kung yung coils na ibang level na cleaning na yon. Okay? So magbabayad ka na, hindi lang isang tao gagawa niyan, dalawa at medyo magastos yan at it will take time. So as much as possible, filter lang talaga. Monitor nyo lang yung filter. Okay, so wala nang tanong dito. Ano yung ipe-present po ng presenter?
Sensible versus latent heat filter.
Sige. Tingnan po natin. Ikaw na po mag-share ng screen.
Okay na po, sir.
Yes, go ahead.
So, wait lang. Ayan. So, good afternoon, everyone. We are Group 2, and reporting alongside with me is Mr. Eric Ogario, and our topic is sensible versus latent heat. May I first ask if I'm audible enough? Can you hear me loud and clear, right? Hello? Naririnig po ba ako?
Yes. Lapit mo lang
Yes.
yung medyo malayo ng konti.
Hello. Yeah.
Sige.
So, for our objectives, so at the end of the discussion, the students will be able to understand the following. So, we first need to define sensible versus latent heat, describe the 6 changes of state, explain
Hindi
superheat.
yata gumagalaw yung presentation mo.
Oh, sorry. Hindi po siya nagalaw. Wait lang. Resume. Yan, sir. Hindi siya nagalaw dito. Ulitan ko lang po yung i-present ko, sir. Ayun, ito, sir. Ayan, sir.
Okay.
So at the end of the discussion, the students will be able to understand the following. First, define sensible versus latent heat. Describe 6 changes of state. Explain superheat and subcooling. Use of 5 refrigeration applications. Define saturation point. And lastly, explain Fahrenheit and Celsius thermometers. So may I call on Mr. Eric Ogario to discuss this topic? That's about it.
Good afternoon po. So, sensible heat, from the root word sense, sensible heat refers to a heat that you can feel or sense. It is an increase or decrease of the temperature of an object when being heated or frozen. In addition, it is the energy required to change the temperature of a substance with no phase change. So, yung from the root word itself, sense, maramdaman natin yung pagbabago sa temperature niya pero hindi nagbabago yung state of matter niya. Next. Latent heat. It came from a Latin word latent, meaning hidden. Latent heat is the energy absorbed or released from a substance during a phase change from a gas to a liquid or a solid or vice versa. It is a heat that is not something you can feel. It often refers to the energy involved in a change of state. So sa latent heat naman, from the Latin word itself, latent meaning hidden, may pagbabago sa state of matter niya pero walang pagbabago sa at bali constant pa rin yung temperature niya. Sensible heat versus latent heat. Sensible heat. Sensible heat is the energy to change. Sensible heat is the energy required to change the temperature of a substance with no phase change. So yun na nga, sa sensible heat, nagbabago lang yung temperature niya pero same pa rin siya ng state of matter. So from the example niya is yung boiling water into frozen water. So nagbago lang siya ng temperature pero same pa din siya as liquid. So, defined for a system without phase transition, describes the energy exchange between matter and surroundings related to a system with changes in temperature. Latent heat. Latent heat is the amount of energy that is either absorbed or released during a phase transition at a constant temperature. Defined for a system with phase transition, describe the changes in the internal energy of matter related to a system at a constant temperature. So, ito yung may wait lang. So parang ito yung nakikita natin yung pagbabago niya from solid to liquid, from the ice cube into ice water. So nagbago yung nagbago yung niya, yung state of matter niya pero same pa din siya ng temperatures. So okay na pala. The 3 types of latent heat. Latent heat of fusion. It is the amount of heat required to melt the substance of a unit mass from solid to liquid, or the amount of heat required to be from unit of mass substance to freeze it from liquid to solid. So yung pinupoint niya is yung from solid to liquid or from liquid to solid. So latent heat of vaporization or evaporation. It is the amount of heat required by the unit of mass of substance to vaporize from liquid to gaseous state, or the amount of heat required to be removed from the unit of mass of substance to condense from gaseous to liquid phase. So basically from liquid to gas or vapor, or from the vapor or gas to liquid. Latent heat of sublimation. It is the amount of heat required by the unit of mass of substance to convert directly from solid to gaseous phase, or the amount of heat required to be removed from the gaseous substance to change it to the solid phase. So ito naman yung from solid to gas or gas to solid. So, sensible versus latent heat example. So yung sa umpisa is negative 5 degrees of ice into the 0 degrees of ice. So sensible siya kasi same pa din siya ng state of matter which is solid pero nagbago siya ng temperature. Then yung pangalawa is 0 degrees of ice into 0 degrees of water. So latent heat naman siya kasi nagbago siya ng state of matter pero same pa din siya ng temperature. Then yung sa third one is 0 degrees of water into 100 degrees of water. So sensible heat naman siya kasi maramdaman natin na nagbago yung temperature niya pero same pa din siya na water. Then yung the last is latent water which is 100 degrees of water into 100 degrees of water vapor. So yung, nagbago siya ng state of matter pero same pa din siya ng temperature.
So thank you very much, Eric, for that matter. So let me discuss the 6 changing states of matter. Originally, it was 5. There are 5 common changing states of matter that we will see here in our country, specifically in our everyday life. But I decided to put the 6 change of the 6 change state of matter so that I will be able to provide additional knowledge for you guys. So change of state is a physical change in matter. It is a reversible changes that does not involve any change in chemical makeup of the substance. There are 6 common changing states of matter, and these are the following: melting, freezing, evaporation, condensation, sublimation, and lastly deposition. So melting. It is the process that causes a substance to change from solid to liquid. It occurs when the internal energy of a solid increases, usually through the application of heat and pressure such that the molecules become less ordered. So I will elaborate this after the next slide. Freezing. It is the process through which a substance changes from a liquid state into a solid state. It occurs when the molecules of a liquid slow down enough that its attractions cause the molecules to arrange into fixed position to become solid. So let me correlate this into a real life scenario wherein we will be able to understand more easily. So freezing occurs when the molecules fix arrange into fixed position. So example, we as a student is an example of a molecules. When one teacher asks us to fall in line, uh, we we will follow. As you can see, when we form a straight line, we are fixed, we are immovable, and at the same time, we are concrete. So, ganun po yung matter, yung molecules na kapag naka-arrange siya into a fixed positions, it becomes solid because they are fixed, they are immovable, and something that is not easily uh, broken. At the same time, in the melting process, when the molecules are dispersed, usually they are not in a solid state or in a solid form. Nagdi-disperse yung molecules. So, kumbaga, coming from a straight line, nagiging kalat sila. So, hindi sila in order. So, that is the reason why matter becomes, or a substance becomes, a liquid from a solid. So next is the evaporation process. It is a process that changes liquid water to a gaseous water vapor. It occurs when energy forces the bonds that hold the water molecules together to break and causes it to become a vapor. So yung vapor po nag-occur siya when heat forces the bonds that hold the water. Kumbaga sa kumukulong tubig, yung mga usok na lumalabas doon sa kumukulong tubig is called vapor. Kasi yung heat, pino-force na yung bonds that hold the water molecules to break. So, yun po. Condensation. It is a process of water vapor turning back into a liquid water. It occurs in one of the two ways. Either the air is cooled and it's to its dew point, or it becomes so saturated with water vapor that it cannot hold any more water. So cooled to its dew point means that this is the certain temperature that needed to be achieved to be able for the condensation to occur. So yun po yung nagre-results ng condensation kapag yung certain temperature ng water vapor ay na-achieve para ito ay mag-result to become a liquid water. Sublimation, it is a process of changing a substance from a solid state into a gas state. It occurs when the particles of a solid absorb enough energy to completely overcome the force of attraction with them. So here are the examples commonly occurs in a carbon dioxide element. So lastly, it is not occurring in our country since we don't have any snow. So deposition is a process in which substance in gas forms change into its states to become a solid form without going through a liquid state. So it occurs when gas particles become very cold. So sabi is when the gas form changes its state to become a solid form without going through a liquid state. So one example of this are the snow, the frost, ice frost that we can see in when the weather is winter. So, yun po. So superheat and subcooling. So the definition of this, superheat is the amount of heat added to vapor above its boiling point, while subcooling is the amount of heat removed from a liquid below its condensing point. So to understand further about this topic, we will watch this video.
Hey guys, this is AC Service Tech, and today what we're looking at is the refrigeration cycle, all right? And we're looking at subcooling and the importance of superheat. All right, so we're just going to do a quick rundown on the refrigeration cycle, and then we're going to go ahead and get started. So what you have is you have a low pressure, low temperature vapor coming into the compressor, and then high pressure, high temperature vapor coming out at its hottest point. All right, then it enters into the condenser coil where it starts to reject heat until it becomes a saturated state where vapor and liquid both exist. After that, it then rejects more heat as a liquid. Okay, it's out of its saturated state, turns into a liquid, and then continues to drop in temperature until it comes out past the valve. That is called the subcooling air. All right, the temperature decrease in liquid form. All right, it continues to go through the refrigerant line until it goes through the filter dryer, which absorbs any moisture in the refrigeration system, and then it hits the metering device where there's a pressure drop. It drops from high pressure, high temperature liquid refrigerant to a low pressure, low temperature, 80% liquid, 20% flash gas, but mainly liquid. After that, in the evaporator coil, as it absorbs heat, it then turns into a saturated state in the middle of the evaporator coil. All right. After it turns into a complete vapor, right after the saturated state, after absorbing heat, right where it turns into a vapor to where it comes out of the evaporator coil at, that's called the superheat. It's the temperature increase in vapor. All right. It then continues to proceed over into the compressor as a low pressure, low temperature vapor, and the process starts all over. All right. So, why do we need subcooling? All right. The subcooling is needed, which is the temperature decrease in liquid form inside the condenser. All right. You need subcooling to make sure that when the liquid finally gets over to the metering device, it has complete liquid and there's no vapor present. If there is vapor present, it's not going to be very efficient. Okay, it needs to be a very, very high or very far spread apart pressure drop. All right, the molecules are all actually spread apart in the evaporator coil when you reduce the pressure, but when you have the high pressure, high temperature liquid refrigerant coming to the metering device, all the molecules are packed real tightly. Okay, so it helps reduce the pressure. All right, when after it goes through the thermostatic expansion valve, the molecules are all spread out. All right, and then the temperature becomes much lower. All right, a very easy way of remembering what superheat is it's the temperature increase in vapor form in the evaporator coil. All right, you can simplify it down to that. All right, because there's only one spot where there's vapor in the evaporator coil, and it's after the saturated state, and then you're taking your temp reading and your pressure reading potentially right after it gets out of the evaporator coil. We usually don't have ports there right after the evaporator coil, so we're taking our reading as a total superheat out at the compressor. But basically, superheat is the temperature increase in vapor form in the evaporator coil. Okay. The condenser, that's where we have subcooling taking place at, and subcooling is the temp decrease in liquid form in the condenser, okay, to where it comes out past the service valve. That is subcooling. So there's only one spot where there's liquid in the condenser coil, and it's after the saturated state. All right, where it comes out at, we always take a temp reading right next to the service valve because that's where we can get an accurate pressure reading at. So that is a subcooling. Subcooling is the temperature decrease in liquid form in the condenser coil. All right, we measure it at the service valve. So that's I just wanted to kind of simplify that for your thought process and trying to memorize what is superheat and what is subcooling. All right, subcooling is used to check the refrigerant charge of a system with a thermostatic expansion valve. All right, so you're actually measuring the temp decrease in liquid right at the service valve of the outdoor unit. All right, that is actually not only just giving you the temp decrease in liquid form, but it's actually also giving you a certain amount of volume of liquid in order to make sure that you have a steady column of liquid going to the thermostatic expansion valve. All right, now superheat is very important. All right, you have to have superheat. Now, a thermostatic expansion valve will actually control the superheat by itself on its own, all right, as long as the refrigerant charge is correct. And the superheat is a temperature increase in vapor form, and you have to have superheat, which means that you're guaranteed to have vapor as far as it going into the compressor. If you have superheat, you know you're going to have vapor going into the compressor. If your superheat is 0, then, or even 1 or 2, by the time it gets to the compressor, there potentially could be some liquid getting into the compressor. So in the case of a thermostatic expansion valve, the thermostatic expansion valve is actually going to be controlling the superheat. But in the instance of a piston or an orifice or a capillary tube, you need to check the refrigerant charge in superheat. Okay, so that's done right at the valve, typically by the compressor, and we're checking the total superheat. Typically, we're not getting a port right after the evaporator coil to check just superheat. We're checking the total superheat at the compressor. All right, so depending on the day, whether with the temperature outside and the wet bulb temperature inside, on one day it could be a very high superheat, a very high target superheat that we have to set the refrigerant charge to. On another day that's cooler outside and cooler inside, and it's less humidity on the inside of the building, then the target superheat that you're setting it at would end up being lower. So you have to set it to the outdoor temperature and the wet bulb for that day on the target superheating chart. You need to set that superheat correctly so that on a cooler day you don't have liquid getting into the compressor. All right, it's a big deal. All right, the other thing is just efficiency. So you want to make sure that you are finding the correct target superheat before you set the superheat. All right, so the superheat is actually the temperature increase in vapor form, and it's set typically at the service valve right next to the compressor as a total superheat. You can check out some of my other videos in reference to how to find the target.
Alright, that's all for the topic. So I hope you understand. So basically, superheat is the point of time wherein the cooling the superheat is a point of time wherein the vapor, the heat is absorbed by the vapor, and subcooling is the point of time in which the heat is rejected and the vapor becomes into liquid water. So where can we use the refrigeration? Refrigeration. So there are many important uses of refrigeration in different industries, and certain number of temperature is a necessity. These are the five applications of refrigeration can be used to the following. So food and beverages. So in the food and beverages industry, refrigeration is important as it plays a role in maintaining the freshness and quality of foods and beverages. Cooling systems are often used in storing foods and beverages so that it will have a better preservation. Pharmaceutical. One of the most important parameters in the industry is temperature. We all know that medicines and drugs are needed to be stored under controlled conditions, usually at low temperatures. That is why refrigeration is a necessity in the field of pharmacy. Electric production. Cooling systems are also needed in production of the electricity to be able to achieve a higher efficiency. Due to it generating heat because of combustion, it is needed also to have a refrigeration to minimize the maintenance of the operations. Data centers. It is a group of servers that distributes data and it naturally produces more amounts of heat during its operation. To prevent the system from malfunctioning, powerful air cooling systems are usually placed to minimize the maintenance operation as well. Home comfort. Refrigeration can be also used in the appliances that we are using at home, which can give us comfort and balance the temperature. Air condition is one of the appliances that can give us a comfort and help balance the temperature within our household, especially during the summer days. So thus giving us a much comfortable feeling, especially in summer season. What is saturation point?
So, saturation point. It is the stage at which no more or of a substance can be absorbed into a vapor or dissolved in the solution. A point in which the capacity of a substance achieve its fullest. So, yung example naman dito is yung a cup of lemonade. So there's a limit to the amount of sugar that can be dissolved in a cup of lemonade. So once na ma-reach na yung limit, kahit anong dagdag pa ng sugar, hindi na tatamis or lulubog na lang. So bale, hindi na kayang may certain amount lang ng sugar yung kayang i-dissolve ng cup of water. So yun yung saturation point niya. Yung example din dito is yung sa kisses. So yung sa kisses na yun, kahit ibabad pa siya sa tubig, once na ma-reach niya na yung pinakamalaking size niya, hindi na siya lalaki. So, yun. Celsius and Fahrenheit. Celsius. Celsius scale is named after Swedish astronomer Anders Celsius, who developed it in 1742. Celsius measured the rising and boiling points of water at sea level and divided the distance between the two into hundreds. Celsius scale or centigrade scale is a temperature scale that is based on a freezing point of water at 0 degrees Celsius and the boiling point of water at 100 degrees Celsius, related to a system with changes in temperature. Fahrenheit. Fahrenheit scale was first proposed in 1724 by the German physicist Daniel Gabriel Fahrenheit. Using a tube filled with mercury and alcohol, Fahrenheit determined his scale based on 3 points. Set the point at which water, ice, and ammonium chloride salt stabilize at 0 degrees Fahrenheit. Fahrenheit scale is temperature scale that is based on the freezing point of water at 32 degrees Fahrenheit and the boiling point of water at 212 degrees Fahrenheit. So, yung Celsius and Fahrenheit, nagkakaparehas lang sila sa negative 40 degrees Fahrenheit and negative 40 degrees Celsius. So, yung sa Celsius naman is, yung freezing point ng water is 0 degrees Celsius. Sa Fahrenheit is 32 degrees Fahrenheit. Then yung boiling point naman ng water is 100 degrees Celsius. Sa Fahrenheit naman is 212 degrees Fahrenheit. Yung body temperature naman sa Celsius is 37 degrees Celsius. Then 98.6 degrees naman sa Fahrenheit.
So here are examples.
Ano yun?
So here is the example of sensor and Fahrenheit thermometer. So our references. Okay, so for our quiz link, here is the link. Let me share this link in our group GC, the group GC, so that you'll be able to understand it and answer it. So thank you very much. That concludes our topic and reporting. I hope you understand something for our presentation, in our presentation. Yun lang po.
Okay, class, tanong muna kayo sa reporters, okay? Kung ano po ba ang gusto niyo i-clarify. Kasi baka mamaya wala po kayong may gusto kayong itanong. So please, tanong na po kayo ngayon para malinawan po. Okay, medyo kailangan ng matinding discussion yung computation ng superheat. Okay, sige, ako muna. Okay. Nakikita ba yung screen ko?
Yes, sir.
Okay. Superheat, subcooling, okay? Discuss po natin. Pag-usapan po natin siya. So, for example, refrigerant R410A. Okay, this is an example of a refrigerant, a blended type refrigerant. So, blended means combination of R32 and R125. So, kaya po siya naging blended. Blended refrigerant can only be added as liquid to the system, meaning you need to flip the tank upside down. Okay. So, from that sentence, liquid, so alam nyo na siguro kung saan ang liquid refrigerant matatagpuan sa system. That's why it's very important na alam nyo sa system kung nasaan ang liquid, nasaan ang vapor. So liquid ay nandoon siya sa evaporator, low side. Huwag kayong magkakarga sa high side. Bakit? Masyadong malakas ang pressure sa high side. Pag pinaandar niyo yung system, kailangan nandun kayo sa low side. Isang safety concern din yan. Okay? So, since as we all know, liquid stays at the bottom and vapor stays above yung tangke. So, kung gusto niyo liquid ang pumasok, kailangan yung baliktarin kasi nga yung tangke, yung hose na pinagkakabitan ay nandun sa taas ng tangke. So babaliktarin nyo para yung liquid ay mapunta doon sa butas, yun yung papasok ngayon sa system. Okay. So sa low side, meron tayong estimated na 118 PSIG, which is a low pressure. Equivalent niya, sabihin natin, nasa 40 degrees Fahrenheit or 44 4.44 degrees Celsius, which is also a low temperature. So state ng refrigerant, vapor, superheated, so addition of sensible heat, kaya siya vapor. Sa compressor yun ha. So nandito tayo sa compressor. Okay, so that is during the entering the compressor. So ito yung estimated natin. Ito yung mga possible na makikita ma-find out natin, makikita natin sa ating gauge manifold. Yung mga temperature na to, itong pressure na to. Okay. So during the exit in the compressor, mataas na po yung pressure. So we estimate it at 446. Then the temperature also rises at about 125 degrees Celsius, degrees Fahrenheit, or convert it into Celsius, so 51. So high pressure, high temperature. So entering, low pressure, low temperature. Leaving, high pressure, high temperature. The state of refrigerant is still in its vapor state. Ayan, vapor state pa rin. So during in the condenser, okay, as it leaves the compressor, entering the condenser, so estimated pressure, so tumaas, then temperature, same din, mataas, still in its vapor state. So during the travel or at the end of the travel to the condenser, so magiging na siyang subcooled liquid. So yan yung cycle natin, di ba? So nagiging na siya unti-unting nagiging liquid because of the heat is being dissipated. Okay. Pagdating naman sa expansion valve, okay, so pressure entering the expansion valve from same pa rin, okay, papasok. So same pa rin. So ganun din, vapor, liquid. So entering the expansion valve, so liquid, okay? Liquid siya. Then, leaving the expansion valve, so unti-unti na siyang bababa, pati temperature bababa, then state of refrigerant, medyo combination na, liquid and vapor. Ayan. So sa evaporator na, low pressure pa rin, low temperature, saturated. So may halong vapor, may halong liquid. Leaving the evaporator, paalis na, still in its low pressure and low temperature, but already in superheated vapor kasi nag-absorb na siya ng heat coming from the room. Okay. So sample question ng subcooling or sensible heat or ano. When the refrigerant is saturated, what would be the subcooling measurement? 0, there would be no subcooling. Okay? Saturated. Okay, so when it is in its saturated state, so walang subcooling na nangyari. Ang subcooling, dito natin siya nakikita sa subcooled liquid refrigerant doon sa may condenser. So yan yun. So that's why it's important na alam nyo kung saan nyo ipipinpoint yung mga state ng refrigerant. So when we say latent heat that is being added or removed that cause change in phase, for example, vapor to liquid or liquid to vapor, but no change in temperature. So sa condenser and sa evaporator, nandyan yung latent heat natin matatagpuan. Sensible heat, heat that is being added or removed in which temperature changes, low temperature to high temperature, but there's no change in phase. So still in its vapor state, which can be found in compressor and the thermostatic expansion valve. Okay, nandyan pa ba? Sorry. Okay. Then, saturation. What is saturation point? Boiling point and condensing point. It is the temperature where the refrigerant will change phase. So pagka sinabing nandun ka na sa saturation point, so nandun ka na sa boiling point or sa condensing point. Naiintindihan yon? Nandyan
Yes
po?
po. Yes po,
Okay.
sir.
Yes po, sir.
Sige. Superheat. It is the heat added to the vapor coming from the evaporator, Okay? So, saan galing yung heat? Coming from the refrigerated area. Doon lang naman nanggagaling yung init. Found at the end of the evaporator. So, dahil nga sobrang na-absorb na ng refrigerant yung heat, so most of the heat causes the refrigerant to become vapor. So, nandun na lahat sa dulo ng ating evaporator. Of course, when refrigerant is heated above its boiling point, or we call it the saturation point. Ayan. So, when you say saturation again, nandun ka na sa boiling point or condensing point. Okay. So, superheat is the refrigerant above its boiling point. Okay? So, yun yung more than. Halimbawa, ang boiling point ng refrigerant ay natin ay nasa -40. Kung mas mataas ka pa doon, so nandun ka sa superheat niya. Naintindihan? So that is superheated vapor. Naintindihan po yun.
Yes po, sir.
Yes po.
Doon papasok na ngayon yung superheat. Ensures that there is no liquid coming back from the compressor. Yun yung pinaka-iiwasan natin, na walang papasok na liquid refrigerant sa ating compressor. Kaya meron tayong sensing valve to help achieve na hindi natin ma-flooded yung evaporator. When we say flooded, oversupply of refrigerant. So pagka masyadong madaming refrigerant, mahirapan siya mag-evaporate. So yun yung iniiwasan natin. Kaya ang gusto natin, sakto lang na mag-evaporate yung ating refrigerant para pagdating sa dulo ng evaporator, pure vapor siya. Okay. Note, it is important that refrigerant stay superheated to ensure that the refrigerant is vaporized going to the compressor. So mas maganda na nandun siya sa above its boiling point. So mas doon sa superheat talaga. So that is above the saturation point. What is now subcooling? It is the heat being removed from liquid that is coming out from the condenser. Okay. So, yung init na natanggal, yan na yung subcooling. Found at the end of the condenser occurs when the refrigerant is cooled below its boiling point. That is the saturation point. So, binalikan lang din natin. Okay? Refrigerant below its boiling point is called subcooled refrigerant. So, kung ulitin natin, kung ang boiling point niya ay nasa -40, kung mababa ka dun sa -40, so we called it subcooled refrigerant. So that is subcooling. Okay? Ensures you have a solid column of liquid going back to your metering device. So ang gusto natin talagang purong liquid, walang bubbles, walang vapor na sasama. Naiintindihan po ba tong part na to? Solid column of liquid. Naiintindihan po ba?
Yes, sir.
Okay. So the difference between high side saturated liquid temperature and the liquid line temperature. So the difference between high side saturated liquid, that is the condensing temperature, and the liquid line temperature. High side pressure gauge is used to measure subcooling. So yung high side is color red, gauge manifold, yung bilog is color red, dun siya sa high side. Pag blue, dun siya sa low side. So, yung high side gauge, yun naman ang ginagamit natin for subcooling. So, alam nyo dapat kung saan nyo titingnan na gauge manifold, kung alimbawa subcooling ang hinahanap mo, titingin ka dun sa high side, which is the red. Kung ang hinahanap mo naman ay superheat, doon ka naman ngayon sa low side kasi nandun siya sa low side. Important things to remember. Ang TXV natin ay maraming klase. So, ito yung example. We have the thermostat expansion valve or the fixed orifice. Ayan. So, yan yung dalawang klase. When checking the superheat and subcooling, the unit should be running or in operation. So, hindi mo makukuha ang superheat or subcooling kung hindi umaandar ang unit mo. Paano mo nga naman malalaman na nandun siya sa above its boiling point or below its boiling point kung hindi naman umaandar yung system. So dapat ay umaandar. Importance of checking superheat and subcooling is to check if the unit is undercharged or overcharged. Yan ang dahilan natin kung bakit natin kailangan alamin na yung superheat natin ay nasa tamang level or ang subcooling natin ay nasa tamang level para malaman natin kung kulang ng karga o sobra ng karga ang ating system. Bakit importante malaman kung sobra or kulang na karga? Pag kulang ang karga, laging mainit ang kwarto mo. Hindi yan lalamig. Pag sobrang karga, yan ang problema naman. Either baka makasira sa system mo, sa compressor mo. Okay, may nag-chat. Ano ba yan? Open mic na lang. Mahina daw po internet ni Raga. Okay. Kung may gusto kayo sabihin na, just open your mic. Baka hindi ko makita o mabasa. Okay. So, use subcooling when using TXV. So, ito yung TXV. Use superheat when using fixed orifice. Ayan. So, hindi pwede na parehas dito mo gamitin yung pagte-testing mo. Depende kasi sa gamit na kung ano yung expansion valve ang gamit. Okay? So, ang difference nito, malalaman nyo yan doon na sa pagdating natin doon sa TXV. Okay? Sana may paliwanag din ng maayos. Okay. So, paano mo malalaman ang subcooling ng isang unit? So, nasa likod niya, ayan, nasa likod ng inyong either split type, yung mga details. Okay? So, nandyan kung anong type ng refrigerant ang gamit sa system at kung ilang degrees Fahrenheit yung subcooling. So, kung nandiyan yan na subcooling na yan na 10 degrees Fahrenheit, so dapat doon sa gauge manifold mo, ay halos nandun ka lang din. Plus 2 or minus 2 is okay. When we say plus 2, minus 2, pwedeng nasa 8 degrees Fahrenheit or 12 degrees Fahrenheit. Medyo okay pa yon. Pero pagka more than that, may problema po yung system mo. Either undercharge or overcharge. Nagigets po ba?
Yes po.
Okay. So, yung low pressure gauge, we call it also compound gauge. Yun yung blue. Yung high pressure gauge, we call it also the pressure gauge, which is the red or the high side. So, ito yung evaporator, ito yung condenser, vapor line, subcooling point, ayan, liquid line. Bakit importante alam mo rin yan? Siyempre, for you to be able to place your gauge manifold correctly at the right valve, dapat alam mo kung nasaan ang high side service valve or low side service valve. 'Di ba? Baka mamaya mapagpalit mo yan. So, mali po ang maibibigay sa iyong pressure. Okay? Ayan. Medyo masyado marami to kasi isang buong lesson ng superheat and subcooling. So medyo hindi natin masyado ng basta ang importante ay alam nyo po ang sinasabi na superheat and subcooling. Okay? Masyadong madami po ito. Sige, try natin ha. Hindi natin uubusin talaga totally. What's important is naiintindihan nyo yung superheat and subcooling. Ayan. So, siguro next time na tong subcooling method kung paano chine-check. Madali lang naman to. Basta, yun na nga sinasabi na check nyo sa likod. Okay, i-check nyo dito sa likod, yan yung subcooling na 10 degrees Fahrenheit, plus 2, minus 2, okay siya. Pero more than that, may problema yung system mo. Okay? So that is subcooling. Ngayon, pag superheat naman, pag sobrang init, ibig sabihin, kulang yung refrigerant na pumapasok sa system mo. Kasi nandoon siya sa sobrang taas na superheat na hindi na kumbaga sa ano ikaw ba temperature mo ay nasa normal 36, sabihin natin normal 36 o 37. Pagka lagi kang mainit na nandun ka sa 37, 38, may problema ka. Okay? So, meron tayong specific temperature ng superheat na dapat doon ka lang din. Yun lang din ang mababasa mo sa gauge manifold. So, pagka less than or more than, may problema yung system. Ganun lang naman yun. Plus 2, minus 2, yun lang naman yun. Naiintindihan po?
Yes po, sir.
Okay. So, ulitin ko ang superheat ay nandoon sa evaporator side. Ang subcooling ay nandoon sa condenser side. Okay? Clear?
Yes, sir.
Yes, sir.
Okay. Clear. Okay. So, anything else, reporter? Meron pa po ba kayong idadagdag?
None so far, sir.
Wala naman. Okay. May susunod pa po ba today? Wala na? Wala naman na susunod today?
Sir, next meeting na po kami.
Okay, sige. Next meeting na lang. Okay. Ano ang type ng exam nyo, reporters? Anong type ng exam nyo sa classmates nyo?
Ano po, ay identification lang po, tas true or false, sir.
Okay. Palitan yung true or false lahat ng multiple choice na for sa lahat po to wag na po magbigay ng true or false, multiple choice lang, 4 na choices. Okay po?
Yes, sir.
Okay, sige. So okay na po tayo. Wala na po kayong tanong doon sa wala nang tanong sa superheat and subcool. Okay?
Yes, sir.
Okay, sige. So, let's take a group pick. Group pick tayo for today.
Sir, may tanong ako, sir.
Ay, sige po. Go ahead,
Hindi
Tyro.
po related sa kanina. Hindi po related dun sa topic.
Hindi related. Okay,
Ano-
unrelated.
Sa ano po, kanina yung discuss yun sa may refrigerant po ng air conditioning po.
Sige.
Normal lang po ba na mainit po, warm air po yung lalabas ng fan?
Saan? Sa condenser?
Opo, sa binubuga po mismo ng fan ng aircon po. Kapag naka-fan mode po, ganun.
Pag naka-fan, natural, kung ano yung temperature ng room mo, yun lang din yung temperature na parang electric fan lang yan. Kasi naka-fan ka lang eh. Walang refrigerant na umiikot sa system pagka nasa fan mode ka. Naintindihan po ako?
Opo.
Okay. Once na pinaandar nyo, yung nilagay nyo yung aircon nyo sa low cool, high cool, or medium cool, aandar na yung compressor nyo, and that's the time iikot na yung refrigerant nyo na yun ang nagpapalamig ng inyong kwarto. Kasi siya ang nag-a-absorb ng heat. Kaya pag wala ka doon sa low cool, medium cool, or high cool, parang electric fan lang ang aircon mo. Naiintindihan po ako?
Yes po, sir. Thank you
Yes,
po.
sir.
Okay, sige. Anything else? Wala na? Wala
Wala
na?
naman na po, sir.
Wala na. Okay, sige. Open your cam. Reporters group pic, mag-screenshot din para madama yung iba. Sige. So, open cam. Okay, sana may natutunan kayo sa mga nag-report Pag may tanong, magtanong po kayo pag may hindi kayo naintindihan. Kasi ayoko matapos yung klase nyo na wala kayo naintindihan. Smile. Ayan. So, thank you very much guys. Mag-attendance po para kahit pa paano reporters pa-monitor kung sino yung absent Sige po. Thank you. Yung may concern, may iwan. Yung wala na po, pwede na po mag-leave. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Bye-bye. Yung may concern, pwede na po natin pag-usapan kung meron po may concern.
Sir, ako po
Yes,
sir.
go ahead.
Sir, pwede po ba, yung ano po kasi, yung email ko po kasi, web mail po kasi sa sir.